Am I still sharing my screen? I think I am. All right, can you all see the practice screen shared here?
Yeah.
Yep, okay, cool, thank you. All right, so let's see, we have a formula, distance equals rate times time. And first we're prompted to say, hey, we gotta pay attention to the units to make sure things stay consistent. So let me blow this up a little bit so it's more easily readable. So D is distance here, R is rate, which is also called speed, it's also called velocity sometimes, and T is time. Units must be consistent. If the units for D are miles and the units for T is minutes, then what must the units for R be? Okay, so let's screenshot that, write some stuff down. Out. All right, so D is miles, so then I've got D, switch colors, RT, D is miles. What should R be if T is minutes? So I can play around with the equation, writing in the units to figure that out. So I want to know what R is. So to solve for R here, I would divide minutes to the other side. So then I believe that R is measured in miles per minute. And hopefully that's one of the options we have for this one. Hours, miles, miles per minute, minutes, miles per hour. So there's the miles per minute, okay, which we come from just playing around with the equation. And then it says to solve this formula for R, which I kind of did in my notes already. Oops, I wrote a P, but that's supposed to be an R. There we go. The miles was my D, and the minutes was my T. So I have R equals D over T. And so that would solve the next one. And again, as far as Tia's question about conversions, it's important to know what each variable represents, how it has to be measured to know if given information matches what the formula is supposed to take. And if it doesn't, then we have to convert one unit to another. All right, so we got miles per minute, we got R is D over T, and then I'm given a situation. So let's screenshot that. New page, and see if we have everything we need. A bicycle rides for 90 minutes. All right, so that looks like they're telling me T is 90 minutes at an average speed of 18 miles per hour. Okay, so miles per hour, that's a rate. So I would say that's my R, 18 miles per hour. How far was the ride to the nearest decimal place? And then they want the answer in miles. So how far, I don't know what D is here. So that's a question mark. But I want the answer to be in miles. And our work on the previous page told us that D should be in miles, T should be in minutes, and R should be in miles per minute. Does my information match that? And the answer is no. Right here, I have hours, but should be minutes. So I'm gonna have to do a conversion. So I have to change hours to minutes in the miles per minute. So the way we do that is we write down the given information. In this case, I'm gonna write it as a fraction, 18 miles over 1 hour. And I'm going to have to look up some information to try and figure out how do I convert from hours to minutes. And since hours is in the denominator and I'm about to multiply, in the conversion fraction, hours has to go in the top. And then if I know how many minutes are in an hour, then I'm doing great. And it turns out, I think I remember that there's usually 60 minutes in an hour. So then to get rid of hours so that they cancel, because they're in opposite positions, this tells me to divide, because that's a division symbol, by 60. So on my calculator, I just ask it, hey, what's 18 divided by 60? Divide. And that's going to be my new rate. So calculator, please. What is 18 over 60? That's not too bad, 0.3. So this is equal to 0.3, and what's left is the miles per minute. So this is now miles per minute from the conversion fraction. And again, this thing right here is what's known as a conversion fraction. All right, so now I have it set up right. I'm ready to use the formula. So the formula said, choose green, D equals RT was my original one. And now I have an R that I can use. So that's the 0.3. And I have a time of 90. And I can just multiply those together. Another way to check that I'm doing this right is if you include the units on these numbers. So if instead I wrote that as 0.3 miles per minute, and I multiplied that by 90 minutes, I need the units to work out to be whatever D needs it to be. And if I multiply miles per minute by minute, the minutes in the bottom cancels with the minutes in the top, leaving miles. And I wanted D to be in miles. That was important. If I skipped the conversion and I missed this Q right here that, that should have been in minutes, and I tried to multiply, so if I took the 18 miles per hour and I multiply that by 90 minutes, notice I have a problem here. I have miles, hours, and minutes all in the same equation and nothing cancels, right? Does it make sense to say D is whatever that is, miles per hour, minutes, minutes per hours, right? This is bad right there because no units are canceling. The units have to work out to be whatever the end result's supposed to be. In this case, the minutes cancel, and I can say, okay, whatever that is. So I think that's going to be, what, 27 miles? Anyone else actually type that in? Yep, that's what Abby got. Yeah. So 3/10 times 90 is 27. The minutes canceled, leaving just miles, which is an appropriate result for a distance, D. So I think I got that there. So again, we just got to make sure the units match when we plug into a formula so that the output has the right kind of unit. Otherwise, we get nonsense, like this up here is nonsense. And I accidentally do nonsense all the time because sometimes I forget to pay attention to the units given. All right, so we think this sucker right here is 27 miles. Let's see if the next one needs any conversions. What must the speed, at what speed must the bicyclist ride to cover 41 miles in 2.5 hours to one decimal place? And then the answer should be in miles per hour. All right, so there's a couple ways to do this one. Screenshot it and pick it apart. Okay, so let's see. What do I have to start with? I have the formula D equals R times T. And then at what speed? So that looks like a question, right? So it's like they're saying, what is R here? Question mark. Must a bicyclist ride to cover 41 miles? Okay, 41 miles. I'm pretty sure that right there is my D in 2.5 hours. That looks like my T. And there's another thing I'm going to pay attention to, that in the answer, they want me to state R as miles per hour. Now, although the original formula said to use miles, minutes, and miles per minute, this one has miles, hours, and miles per hour. So I could stick with these given units. Because they seem to be consistent instead of doing a conversion. So I could stick with the given units, and units are things like miles, inches, feet, Celsius, cents, and I'll show why I think they're consistent. If I plug just the units, forget about the numbers for a minute, into the formula here, I got D is miles up there equals, they're telling me that R should be miles per hour. So I'm going to write miles per hour. And then here they gave me T was hours. And if I multiply this fraction times hours, you could view that as hours over 1. Since hours is in the top and the bottom of a multiplication, they cancel out, leaving just miles. Miles equals miles. This is good. It's consistent. I didn't end up with a jumbled mess of miles times minutes divided by hours with nothing canceling. Things worked out nice. So in this case, since the units do work out together, I'm not going to worry about minutes. I'm just going to plug things in as I have them. So again, I'm going to plug into D equals RT, and I am given D is 41. I'm asked to find R, so it gets to stay R, and I'm given T is 2.5. To solve this, I would just divide by the 2.5. So whatever 41 divided by 2.5 is, should be my R. If you're still worried about the units, you could write everything in with units, the numbers that were given. So alternately, I could have wrote 41 miles equals R times 2.5 hours. And then to solve that, I would divide both sides by the 2.5 hours to get R alone. So in a lot of science classes, they have people keep the units in the equation to make sure the units match up with whatever we're trying to do. A number divided by itself is 1. 1 times R is R. And on the other side, I have an answer in miles per hour, which, hey, that's what I was asked for up there. So the last step would just be to figure out what the heck is 41 divided by 2.5. And 16.4, mine came out very nice. They said to go to 1 decimal point, so at 1 decimal point already, no rounding necessary for my version. And then my paper notes are kind of assuring me that I have the units set up right. So either here, that tells me the units are okay, and then this little check up here told me the units were okay. So anytime you have a formula where there's different kinds of measurements being plugged in, always double check that the units will work out in the end. And that is complicated. It takes a lot of thinking. I have to write a lot of notes to make sure I get it right. It's not obvious unless I've done it before within a reasonable amount of time, like yesterday or today. All right, so other questions. Oh, let's see. question 6 of homework 3.7. Am I reading that right? Okay, let's take a look. And let's submit it just for fun, see if I did good today. Hey, I did good. Anytime you do one of these problems where you get help from me or a friend or a tutor or watch the video, make sure you do a similar one after to make sure you can do it on your own. Super important. All right, so I'm going to leave this assignment and go to homework 3.7, number 6. Oh, let's switch recordings. Let's